Good morning, everyone, and welcome to today's webcast, Reducing Flaring and Emissions in Production Facilities. I'm Craig Fleming, Technical Editor of World Oil, and will be your moderator today. iProduction is a modern approach to multi-well processing focused on the reduction of greenhouse gas emissions. This includes well pad processing, gathering lines, and central processing facilities under a single interface with autonomous control. In this webcast, Laura Schilling and Isabel Chan will be detailing how TechnipFMC's iProduction ecosystem can effectively address the facility GHG challenges of the future and reduce LP flaring by 60%. iProduction also has a smaller footprint, lower total cost, and uses modules prefabricated off-site for faster field startup and lower operating expense. Companies have adopted this ecosystem, have seen operations become more streamlined with reduced GHG emissions, reduced capital expenditures, and decreased time to first oil. TechnipFMC's proprietary AOS is the dynamically optimizing heart of iProduction. Laura Schilling is the Senior Vice President of Measurement and Production Solutions. Laura is responsible for measurement, production software, and automation within the surface ecosystems. Prior to joining TechnipFMC, Laura was president at Superior Energy Services. She also spent over 13 years at Halliburton in a number of roles, including operations, global business development, and investor relations. Laura has an MBA from Rice University as in based in Houston, Texas. Isabel Chan has held the role of product manager for onshore production for the past 2 years. Isabel is focused on cooperating with customers to create solutions to minimize emissions and maximize oil production. Isabel joined FMC Technologies in 2012 and held several positions in surface and subsea focused on engineering and production. Prior to TechnipFMC, she was process engineer at Bechtel. Isabel has a BS in chemical engineering from the University of Texas and is based in Houston. Before we get started with today's presentation, let's review some general housekeeping notes. Following the presentation, we'll have a short question and answer session. You can participate in the Q&A session during the presentation by typing your question in the Q&A box located on the bottom left corner of your screen, and then click the Submit button. You may enlarge the slide window at any time by clicking on the arrows on the top right corner of the slide area. The slides will advance automatically throughout the event. If you're experiencing problems with the program, press F5 on your keyboard to refresh the presentation. You can also visit the webcast help guide by clicking on the Help button below the slide window. Now let's get started. Laura?
Thank you so much, Craig, for the introduction. Today is very exciting for us, as this is one of the first opportunities we've had to share the details of the system that we believe is poised to make such a difference in production operations in unconventional basins. And I'm proud to share that our team started working on these technologies actually several years ago, which led to partnering with some very forward-thinking operators on how they could reduce emissions. And even before many in the industry were thinking about ESG scopes 1, 2, 3, sources of methane emissions, our teams were together, and they were knowing that there are better ways of working, better ways of doing what we do, and we have the technology to get us there. So a few weeks ago, there were some big headlines with regards to global oil and gas leading companies. Investors are demanding higher returns and driving a change in accountability for environmental impact. And a key question on our customers' mind has been, how do we produce at the level we've promised and reduce emissions at the same time? And in our view, after years of research and a number of these conversations, the central production facility has been one of the biggest opportunities to help operators reach these goals.
Yeah, when we started looking at the central production facility 3 years ago, we focused on minimizing emissions through reimagining the design. We interviewed operators to see what their challenges were and how we could do things differently. We started by eliminating equipment like taking away tanks and minimizing the total number of connections. But now we've discovered that better process automation and data can unlock how you can optimize the operations of the system to lower emissions. So it's easy to see flares when you're driving down the road in West Texas, but now flaring can be viewed from satellites and monitored in almost real time. The animation on the right shows that the visualizations that are possible using satellite imagery, and using these satellites to estimate that flaring volume. The charts on the left capture just how much emissions have potentially been underreported in the US. Regulations in several regions have gotten stricter and stricter. Colorado has effectively banned flaring, and North Dakota has limited flaring volumes to 8% of total gas production and removed the allowance for those short-term flaring operations during completions. These changes have resulted in operators shutting in or dialing back the wells in order to meet these regulatory requirements.
So as we've been walking through different sites, we know a number of operators are working on the measurement piece and leak detection. Measurement is so important, and these are absolutely necessary for us to move forward as an industry. And this is leading to a lot of conversation about how we can capture emissions after the fact. But what our system and our team focused on is actually prevention of the emissions in the first place. In particular, what can we do to proactively engineer out the need to flare? And what can you do up front to remove emissions-related equipment? And we think of this a lot as analogous to our safety journey as an industry. In the beginning, we identified risks, and then we thought about risk mitigation, and we thought about things like PPE and better tools, better reactive processes and training. We started a conversation around left of zero. We talked about bow tie principle, but then finally we thought, let's engineer the safety risk out as much as possible. Let's engineer out the risk where we can to avoid pinch points, working in the red zone, being in confined spaces. Let's focus on prevention. And this is very similar to that journey.
Yeah, I think a lot of us are on the same page as where we'd like to be. We want to emit less and continue to produce. The question of how to lower emissions starts with knowing where your emissions are coming from. So we'll share what we've learned about where the emissions are coming from in a traditional setup. So central production facilities come in lots of different shapes and sizes, but they often have very similar challenges. I think it really boils down to maybe 4 general things. It's tough to measure your read vapor pressure, or RVP, in real time. The oil is often too hot. Vapor recovery units trip, and seals leak. So we'll step through these one by one. There really hasn't been an easy way to measure RVP and constantly monitor the quality of oil. You can take these samples regularly, but that can be pretty cumbersome. There are machines that automatically take RVP measurements, but those need to be cleaned out and calibrated every 10 samples. They're more suited for the refinery than the oil field. And all these complications lead to our second challenge.
Well, and as Isabel points out, since there's not been a fast and consistent way to test the oil stabilization quality, otherwise known as RVP, operators tend to set temperatures and pressure settings in the system for a static baseline. It's very convenient. However, for example, heater treaters are the main way to put heat in the system. When the ambient temperature plunges and the sun's down long enough to start affecting oil at 2 a.m., you probably don't want an operator adjusting the heater treater. So you set the parameters to make sure you meet that 2 a.m. threshold. It makes sense, but for all those other hours of the day, it could mean that you're losing oil out to the flare line. And similarly, many parts of this process are still very manual, including step-down processes that tend to be inefficient, trial and error, leading to more gas being produced in the process than is really necessary, which results in more gas, more flaring, and eventually more emissions.
Yeah, and speaking of that hot oil, when oil hits at atmospheric pressure, you'll see a lot of those light ends gas off. So you've got great conditions to eat away seals on beef hatches. And not only does that gas affect the seals, but you're putting a lot of strain and work on your vapor recovery units.
So finally, the vapor recovery units. They are standard for capturing gas, but often demonstrate major reliability problems. It's not hard to see why. There's such a focus on improving the reliability of the VRU. When the VRU goes down, that gas, it goes straight to flare. It's a flaring event. And there are regions that are too challenging for VRUs to operate. So in those cases, all the gas goes straight from the heater treaters and to tanks to flare. And this leads us to the #1 driver of emissions on the site. Flaring accounts to 70 to 90% of a site's total emission. So anything we can do to minimize flaring is a very good thing. So we've seen a lot of approaches that focus on optimizing these individual pieces of equipment that we just discussed, but it's not usually enough to make the step changes that are being demanded now. Our approach uses unique design, digital integration, and process automation to optimize the entire production operation and deliver more liquids to the sales line and less gas to the flare.
So after 3 years of working on this, talking to customers, and deploying our first unit, I'm proud to share with you what we've created. iProduction replaces the central tank battery and delivers more on-spec oil and minimizes emissions. You'll notice there are no tanks on this site. Instead of using arbitrary rules of thumb, our proprietary system accurately predicts the RVP of the oil, allowing us to remove those tanks from site and reduce flaring. By using our digital platform to control different parameters, we can reduce the amount of gas going to the VRUs and coming from tankage, which results in less flaring and fewer emissions. We want to leverage our expertise in efficient design and packaging of separation and process equipment from our offshore and subsea experience to create value for unconventional operators. This system can process up to 20,000 barrels of oil per day with 60% less equipment and incorporates that digital platform for remote monitoring and preventative maintenance. Our modules work in concert with a digital control system to intelligently adjust for the challenges throughout the life of the well.
So let's talk about where the solution would fit in among different types of infrastructure. A lot of different operators have different approaches to how they've networked their fields. And sometimes they don't even use the same design in the same field. But on the left, you'll see a sketch of a full pad processing facility where 4 or fewer wells are feeding a pad. iProduction is probably not the best size for that configuration. A minimum of about 10,000 barrels per day would be necessary to take advantage of all the benefits of the system that we're going to discuss today. Now, in the middle, there's an illustration of a partial pad processing. When pad processing, maybe say for allocation purposes, are combined with central production facilities for stabilization purposes, that's the perfect combination for a pared down version of the iProduction system. Now, the modular nature of iProduction allows it to handle different types of incoming flow and conditions, and the system can be even utilized as a degassing station. On the right, there's a depiction of a full central production facility. The full system was designed for multi-phase flow from many wells, and the system can process between 10 and 20,000 barrels a day, 50 million scuffs of gas, and about 35,000 barrels of water per day. However, these rates can vary by oil type and temperature and a number of other variables. But we most frequently heard from clients and in our study and early conversations about emissions issues was that the large central production facilities were really where the challenge lies.
So on this next slide, we show a typical side-by-side of a traditional facility with iProduction, and that's actually at scale. The iProduction system requires 40% of the footprint of the current design. The footprint and spacing requirements for tanks can take up quite a bit of real estate. So removing tanks not only saves you space, but also emissions. Tanks indirectly cause emissions by making life difficult for VRUs and directly cause emissions through their feed patches. And flaring is really a day-to-day occurrence. We compared one of our sites to a neighboring site with similar flow rates. On our best days, we reduced flaring by over 90%. But that comparison can vary a lot from day to day and how well your equipment's behaving. So in this next section, we'll dive deeper into exactly how we hold up our end of the bargain in reducing emissions.
So in collaboration with our customer in the Permian, we set ambitious targets for our design to reduce emissions by 60%. They shared their basis of design and existing cost structure that allowed us to fully examine optimization opportunities. And our customer was focused on reduction of construction costs and direct field labor hours. And we were able to collaborate with them at every step of the process to realize a fully operational system that meets the targets, in some cases exceeds, and reduces the total equipment count. So many of the realized benefits come from the consolidation and packaging of equipment, in this case from 22 modules down to 6. The lower equipment count reduces maintenance, installation cost, and venting. Safety risk is also decreased due to the reduction in manual intervention the system requires.
Yeah, and that reduction in manual intervention comes from our digital components. That enables us to do remote operation and increases opportunities for optimization through automation. Our proprietary technology allows, for the first time ever, constant monitoring of sales quality of the oil in real time to ensure maximum oil to sales, increasing revenue.
So I just want to make sure everybody heard what Isabel just said, because it's a pretty revolutionary statement that we're able to constantly monitor the sales quality of the oil and get a real-time RVP through our system in order to optimize the system all the way through. The iProduction system is a whole new level of control and visibility. And in the early life of the well, the oil is hot and volatile components are allowed to be captured in the gas phase. But by driving volatiles back into the oil, we can increase oil production while reducing the flaring. We're not just putting methane issues further down the value chain for someone else to deal with in this process. We're actually enabling the conversion of gas to liquids, which increases daily production while reducing the need to flare. We've also looked at how we can interpolate this technology to retrofit existing facilities with the goal to bring very similar results to existing assets. It's a very exciting development.
Yeah, I'm really excited about it too. One of the key enablers of the system is our advanced oil stabilizer. I feel like I get two reactions whenever I say stabilizer. Either your reboiler is going to be full of salt, or that doesn't look like a column. Well, you're right. We don't have a reboiler, and this definitely isn't a column. The system combines the functionality of a heater treater and vapor recovery tower, much like a stabilizer, but it has a much simpler function. The system utilizes an intermediate heating system and an integrated heater to provide better efficiency with low NOx burners. So this way of heating is far more reliable than burner tubes and also takes different types of emissions in mind. The package allows us to control the temperature of the oil at low pressures that can result in more oil than heater treaters and VRTs. The edge-based RVP monitoring system allows adjustments to be made during flaring events to minimize flaring and maximize oil. So let's take a look at an example in the video to follow. So in this scenario, we have a system that has iProduction. The data is streaming in from all different pieces of equipment to the control system that is remotely viewable through a tablet or browser. There's an overflow tank there to help operations get over their apprehensions on a tankless system. So tank vapors are going to VRUs, and one of the VRUs trips and goes down. The flow rate goes up to the flare goes up, and you can do a series of interventions, either manually or automatically, to turn down that rate going to flare.
So like many parts of our industry, digital automation is changing how we work and what we can control in the field. Previously, digital twins existed in the cloud, but focused on monitoring and weren't able to give us the true real-time responses to what was happening in the system. Now, today, the diagnostics and processing take place on the edge, and automation and updates and additional changes can be dialed in remotely through the cloud.
Yeah, the system divides and conquers. So we can track long-term trends in the cloud and focus on immediate interventions at the edge. So these digital insights are key to maintaining reliability with the VRU especially, but also optimizing the entire system.
So far, I know you've seen a number of illustrations in our slides that we're using today, but we thought we would close with a picture of an actual system that's deployed in the field. Now, these layouts can vary, but this obviously is an impressive sight. More exciting, though, are the results that we have seen through our studies and the deployments. The system reduces emissions and flaring oftentimes by over 60%. The process creates more on-spec oil to sales, and meanwhile, through digital automation, we have unparalleled ability to calibrate and respond to the dynamic conditions that Isabel's talked about today through the facility, which increases reliability and reduces the need for manual interventions. So thank you guys so much for your time and interest in the presentation today. We're excited to share what we've learned through all these innovations, and the team continues to work and move forward. I want to thank many of the teams of operators who have shared so much with us and who have shared our passion for finding a better way to deliver in the field. We invite you to reach out to us to discuss collaborating on how you can reduce flaring and emissions in your own existing or new facility as well. So Craig, we look forward to questions from the audience.
Hey, thanks, Laura and Isabel, for that informative presentation. We'll now transition to the question and answer portion of our webcast. The audience can continue to submit questions in the Q&A box located on the bottom left corner of your screen. Now let's get started with the first question. Can you share what is the average increase in production to the sales line you can get using this system?
So average is sort of, it really depends on the site. So we've seen up north, you can go between 50 to 100 barrels of oil per day in some studies, and some fields you might not see any increase. So it just really depends on what your setup is.
Great, good answer. How soon can you see a difference in flaring and emissions after you implement the solutions?
I mean, through the digital automation that we have that we've described as part of the system, it's a pretty immediate impact. Once we are calibrated, we're able to run forward in that new system, and it's pretty immediate.
Yeah, it's kind of crazy how fast you can see a difference.
Perfect. Next question, is the application of these technologies limited to gas or oil or specific oil types?
I think it's really more of a liquids targeted system for now. It doesn't mean that there can't be applications to gas fields, but we're really focused on delivering value for those liquid fields.
Good answer. I see. Can you share some of the detail on the process your team goes through to plan and deliver these solutions?
All right. So typically what we do is we sit down with engineers and we try and figure out, what does your site look like? And then maybe where are some of the places where there could be efficiency gains. And of course, we have our own solutions, but we're really trying to find the best optimized system for our customers. And so we'll sit down and discuss our goals, and then we'll maybe go take a visit to site and just make sure that we really understand what's going on. After those discussions, we'll meet with the engineering team and we'll make sure that our HAZOP system will fit in well with what they've already got. We have the right connections. And then it's basically 6 months to deployment on an average time scale. So.
But I think what's been unique about the interactions is our operator partners have really opened the kimono, so to speak, and shared a lot of data with us. They share, if they already have some sort of edge diagnostics coming through their system, they share those with us, as well as any of the production data from the previous amount of time that they've been running the system. So I think it helps to have full transparency between both the operator team and ourselves. to be honest about where those areas of optimization. What we found too is that there's a lot of quick wins sometimes that just come through better calibrating the equipment or calibrating it in a different way than what the operator may have done previously. So between the quick wins and then kind of optimizing for the future, the collaboration in the process tends to yield some really good results.
Thanks, Laura. Next question. How can you manage gathering upsets or bottlenecks without tanks on site?
That is the number one question I feel like we've gotten from all the interactions. So.
Yeah, I mean, I specifically added an overflow tank to the animation so that people can feel a little bit easier, you know.
But it's definitely a step change in how people have designed these facilities in the past.
Yeah.
Isabel, share how we're able to get through it.
Yeah, and so I think, you know, it has to be a blend of different things, right? You have to design the entire layout of all of your systems in order to accommodate that, you know, flexibility. If you want a common set of tanks between a bunch of different places so that you only have one set of tanks to worry about, or you only have one set of issues to worry about on that specific site, then that can also, you know, help transition operations to a completely tankless facility. But we find that when you use preventative maintenance and you also plan for those upsets in advance, right? I know you can't really plan for upsets, but when you have different mitigation tools, then everyone can feel comfortable with a tankless facility.
Sounds good. Are these solutions only applicable to new facilities?
So I can take that one. The answer is no. So we've shown really the reimagining of the entire of a greenfield design going forward. But what we have found is, very excitingly, a number of these technology and digital processing components can absolutely be retrofitted into an existing facility, and we can, through some of the control that we've talked about and automation, we can drive the same type of results. I think the process of engagement is the same, where when we work with an operator, we need that data. We need to be able to talk about the design and where they've had hiccups in the existing facility, strengths and weaknesses evaluation. But a lot of this technology can absolutely be applied to existing facilities, which, you know, given the infrastructure we have in U.S. unconventionals, it's very exciting to be able to say this, that we have a solution that could be applied to what's out there already.
Perfect. Do operators create a centralized plan for flaring? How are the flaring emissions tracked and verified?
So often they're tracked only by an estimating tool. So a lot of the operators have environmental teams, right, that will have a ratio based on your the amount of throughput that you have in your site for what you have to report as flared gas. Now, that doesn't sound like you're measuring anything, and that's correct. There's not a requirement in every single state. Some states do require measurement and reporting of flaring, but that's not true everywhere. But it does seem like that is the trend line. So you might see more direct measurement of flaring, and that would result in, you know, probably different actions being taken by the operators. And I have seen some centralized flare plans, but the planning is only as good as your VRU uptime often.
And it's a key point, right? It's early days, and what we see a number of clients doing to improve their measurement. We see everything from, you know, drone flyovers to sensors on location. And in some cases, these are new tools that people are bringing to site. So this is all, you know, I'd say pretty new processes that operators are using to add data into the equation to make it more consistent going forward. But with that information, then you can make a better plan.
Yeah, and here at the state of New Mexico is actually using FLIR cameras to measure methane emissions now and NOx emissions. So those are two really important things to think about for the future.
Sounds good. Have you identified any benefits from iProduction onshore which could be realized offshore?
Well, we're smiling at the question because in a lot of ways for our the way this evolved for TechnipFMC is actually the other way, is there's a lot of best practices from offshore, and we have from our subsea business and a lot of the competencies there that we were saying, hey, why are we doing this best practice offshore, and we need to bring that onshore. And we sort of thought about it the other way, because right now in subsea, when you look at multi-phase, is already a key part of the process, whereas for unconventionals, that has not been fully adopted just yet. There's actually a lot of best practices on the offshore side that we looked at bringing into the system the other way. And Isabel, there might be a couple of I'm forgetting from offshore, but I think it's definitely applicable.
Yeah, and some of the things that we've done onshore now, we can take back to offshore in order to realize some of the cost benefits and some of the monitoring benefits that we're getting. So I think there's definitely applicability depending on what you really want to do offshore with some of the tools that we've created.
Probably, you're right, a lot of the digital processing side, because the equipment tends to be a bit similar, truthfully. So I don't think it's an equipment optimization piece so much as the digital automation that you can bring in that makes the difference.
Great point. Thanks for that. Would sand be a problem for the separation system?
So no, we actually have an integrated sand jetting system, and that will allow you to stay online and remove sand in your inlet separator. So we have forks inside of that separator to see when you filled up with sand, and then we can deploy one of our service technicians to go and flush that sand out. And you can do it while you're producing. You don't have to, right? You can bring the system down and depressure like you normally do, or you can keep running through the separator and jet the water in, flush the sand out, and keep things running. One
of the best parts about that system is that it doesn't require manual intervention. The technician can go out, but they don't have to shut everything down, get in a confined space. It's an automated flush that she's describing, and we take the person out of the risk profile.
Yeah, there are no shovels involved.
Yeah.
Perfect. Does iProduction require a total facility upgrade or minor modifications, especially considering the significant reduction in equipment footprint?
It's honestly up to the different people who are designing and engaging with the system, right? Each customer has a different need. I think to realize the full benefits of getting more oil, less emissions, of course, for greenfield sites, I would suggest the full iProduction system. But there are also different modules that you can implement in different parts of the system. For example, if you're having, gas fluctuations in your oil gathering lines, you can put one of the modules in as a degassing station and help, even out your oil flow in that line.
Thanks, Isabel. In today's environment, reporting of carbon emissions is almost a must. Is this integrated system tracking this information?
That's a great point. We have a digital predictor on what your actual emissions are based off of all of the different metrics that we have of the system, right? So burner efficiency, and we have models at the edge that are constantly calculating this based on a number of different factors. I don't want to give away too much there, but we do have that considered as part of the baseline for what's offered with our digital offering.
Perfect. Next one. Would iProduction operating philosophy work with heavy crude oils where heating is required in the primary separation?
So I think we would have to do a little bit more development to suit heavy oil. It's not that it's not possible, but with the modules that we've created today, it's really perfectly suited for unconventionals and not so well suited for heavy oil. So it's on the roadmap, just maybe not for the immediate future.
Great. Do you prefer oil pipeline hookup or can oil be trucked?
It doesn't, well, for the system, maybe we'll take this in context as the effectiveness of the system. The system doesn't matter. at the end of the day.
But if you're trucking oil in, then you probably don't need to put it through this system, right? Because if it's being trucked, hopefully it's being transported safely and it's already at RVP. So really this is designed to take oil off of a gathering line or straight from the well pad. So maybe a little more upstream from where this person is referring to.
Understood. How do you foresee reusing the data captured beyond the initial operation of the facility?
That's a fantastic question. And that's another area that we get very excited about, because the diagnostics that you're capturing on the edge, those can be used for a lot of different optimization opportunities. So, again, it's kind of up to the operator with the goals that they have and what they're trying to achieve. But everything from basic health condition monitoring of the equipment to optimizing the energy flow through the system and uptime. I mean, there's actually limitless possibilities of how you can use the data that we're collecting on the edge for looking back and doing post-mortem type reviews, and even calibrating the system better looking forward.
Yeah, and you can see different changes as the well is changing its characterization as well. So that's really nice, is that you can see the direct results and you don't have to go and model all of that.
Yeah, Isabel makes a good point, because getting back to the real-time capability of seeing the dynamics in the oil, and that hasn't been possible before. So a lot of times I feel like the operators are learning a lot of new information too when they have the system of what they can better plan for and what's coming through in production.
Great, thanks for that answer. Is DVR used to allocate uncertainty within the system?
I'm not familiar with that specific acronym.
So we might have to get back to you on that and follow up with a more specific question.
Sounds good. Here's another one, maybe a little bit of overlap. Can iProduction apply to gas wells?
So I don't think it's ideal for gas wells. And the reason being, it's probably not in the right price point, and it's probably not in the right processing windows. It's not to say that certain parts of it can't be used, but for example, there's no glycol or TEG dehydration system on this. So you would still be getting, gas with water in it, which is probably not what you want in a gas heavy system.
Understood. How does the system affect the need to power at the location? Meaning, will the iProduction need more power to operate?
So marginally, right? So if your site is using all pneumatic valves, and all those pneumatic valves are using gas or air, right? You have that marginal or the incremental electric actuator increase, right? So not that much. Your VRUs, you're actually using less power on your VRUs because we're trying to optimize the total gas volume and minimize that amount of gas that's going to be going to the VRUs. So it depends, unfortunately. So if we want to talk about total power consumption, that's another question. But in general, no. We have plans in the future, which I can't talk about, but I think for today's version, no, it does not require more. Maybe it probably evens out. So.
Perfect. Seems like there is a clear case for the use of pre-wellhead multi-phase flow measurement. Is this technology a current or future component of the optimization solution?
So ideally, we would have our multi-phase meters on the inlet of each of the wellheads, and that gives you even more information and more data about which specific wells you want to turn up and down, and that is part of what is out of that full digital optimization, that full system. Often people, I think we can use it, right? And it is built in as a module. It's a piece that we can include, but it's not perfect for every operator, right? Everyone has different challenges and they have different ways that they need to operate. So again, I'm sorry, the answer is it depends.
Well, I think we highly recommend it if the operator is set up for it.
Yeah.
And then it's core to the system.
Perfect. Hey, that's all we got time for today. We'd like to thank you all for attending today's webcast. We'd also like to thank TechnipFMC for putting together this timely and informative presentation. Finally, an on-demand version of this webcast will be made available in the coming days and will be emailed to everyone. This concludes our presentation.
Mm-hmm.